Right now, all 30 members of one of the government's most sophisticated long-range forecasting model ensembles agree on something that almost never happens with this level of unity: the weather pattern currently baking the central United States. And starving the Pacific Northwest of rain is about to reverse, region by region, into something close to the exact opposite of what large parts of the country have been living through all summer. This is not a single meteorologist's hunch. It is the product of a rapidly strengthening super El Nino, potentially on track to become one of the strongest ever recorded, locking in what scientists call a split-flow jet stream pattern, a configuration capable of reshaping storm tracks, temperatures, and precipitation across the entire continent simultaneously. Today, we are going to break down exactly what this pattern flip actually is, why it is developing with this much model agreement behind it, and what it specifically means for whichever region of the country you happen to call home. If tracking real, current forecasting science, not just the scary or exciting headline version of it, is something you want to keep doing, subscribing means you catch the next update the moment new model data comes in. Let's start with the basic mechanism driving this entire shift, because understanding how El Nino actually reshapes the jet stream is the key to understanding everything that follows. El Nino is a periodic warming of surface waters across the central and eastern tropical Pacific Ocean, and that warming does far more than simply heat the water directly beneath it. It fundamentally reshapes global atmospheric circulation, and one of its most consistent, well-documented effects on North America involves splitting the jet stream, the fast-moving river of air, high in the atmosphere that steers nearly all of the country's major weather systems into two functionally separate branches. During a strong El Nino winter, a persistent area of low pressure typically forms in the North Pacific, and that low pressure pushes the polar branch of the jet stream further north than usual, allowing warmer than normal air to settle across the northern United States and western Canada. At the same time, the subtropical branch of the jet stream gets dramatically amplified, supercharged by the extra energy and moisture rising off that unusually warm equatorial Pacific water, creating a corridor of frequent, moisture-rich storm systems tracking across the southern half of the country. Two separate jet stream branches, doing two very different jobs, across the same continent at the same time, is exactly what meteorologists mean when they describe a split flow pattern. Picture the jet stream normally as a single winding river of fast-moving air circling the globe, steering storm systems along roughly one continuous path as it flows from west to east. A split flow pattern breaks that single river into two separate channels, running at different latitudes, carrying different air masses, and behaving according to different rules. The northern channel, pushed unusually far poleward by the persistent Pacific low pressure, tends to starve the regions beneath it of the storm systems that would normally track through on a more typical winter, allowing high pressure and milder, drier conditions to dominate instead. The southern channel, supercharged by the extra energy rising off unusually warm equatorial water, becomes a kind of storm superhighway, capable of carrying system after system across the same general corridor for weeks or months at a stretch. A single location can end up on either side of that split, and which side it lands on determines almost everything about what its winter actually looks like. This year's version of that pattern carries an unusual amount of weight behind it. According to the latest analysis, the current El Nino is intensifying rapidly enough that forecasters are now describing it as trending toward record strength, potentially becoming the strongest event of its kind ever measured. NOAA's own outlook gives roughly 97% odds that the event persists all the way through spring of 2027. And in one recent analysis, all 30 members of the GFDL SPEAR model ensemble, a large batch of slightly varied simulations, run specifically to capture a realistic range of possible outcomes, agreed on the broad shape of the resulting winter pattern. That kind of near-unanimous agreement across an entire ensemble of models is genuinely rare in long-range forecasting, and it is a large part of why meteorologists are treating this specific pattern flip with more confidence than they typically extend to a seasonal outlook this far in advance. Understanding why an ensemble of 30 separate model runs matters more than a single forecast helps explain exactly why this level of agreement is significant. Long-range forecasting models are inherently sensitive to small uncertainties in their starting conditions, tiny variations in initial data that can compound over weeks and months into meaningfully different projected outcomes. Rather than relying on one single model run and treating its output as a fixed prediction, forecasters generate an ensemble, running the same model, dozens of times with slightly varied starting conditions, then examining the full spread of resulting outcomes to see how much the members actually agree with each other. When only a handful of ensemble members agree on a given outcome, forecasters treat that outcome as one plausible possibility among many. When all 30 members of a major ensemble land on a similar broad conclusion, as happened here, it signals that the underlying signal driving that outcome, in this case the strength and influence of the developing super El Nino, is powerful enough to overcome the small starting differences that would otherwise scatter the model runs toward more varied conclusions. To understand what a pattern like this is actually capable of, it helps to look at how it has played out historically, because this is not the first time a strong El Niño has reshaped an entire winter across North America this dramatically. Previous strong events produced their own versions of this split-flow winter pattern in 1982 and 1983, again in 1997 and 1998, and once more in 2015 and 2016. The 1997 to 1998 event in particular is being used by several meteorologists as a working roadmap for what this winter could look like, since it remains one of the strongest modern examples of a major El Niño reshaping weather across the entire continent. That winter featured repeated storms slamming into California, widespread heavy rainfall and flooding, and a genuinely healthy mountain snowpack across much of the west, while the southern branch of the jet stream stayed exceptionally active, fueling storm after storm from California all the way across to the southeast. The 1997 to 1998 El Niño remains a touchstone specifically because its ocean temperature anomaly reached a strength comparable to what forecasters are now projecting for this year's event, giving meteorologists one of their clearest available real-world analogs for what an El Niño of this magnitude can actually produce once its effects fully mature. That winter is remembered across California in particular for the sheer persistence of its storm activity, month after month of systems tracking through the state, overwhelming rivers and hillsides that had gone through a typical dry summer beforehand, not entirely unlike the drought-stressed landscape much of the West is heading into this year as well. Emergency officials who lived through that earlier event have specifically cited it in recent planning discussions, treating it as a genuine benchmark for the kind of sustained, repeated flood risk a similarly strong event could produce again. Here is what makes this specific event different from all three of those historical comparisons, and why forecasters are being careful not to simply assume history will repeat itself perfectly. This El Niño is developing on top of a global climate baseline warmer than any of those previous events ever had to work within. And stronger El Niño events have historically shown a tendency to bend the so-called textbook rules rather than follow them precisely. A newly identified ocean anomaly in the Indian Ocean, called the Indian Ocean dipole, has also emerged alongside this super El Niño, adding an additional layer of tropical forcing that is expected to combine with the developing El Niño circulation and further influence jet stream patterns across the entire northern hemisphere this winter. Two major tropical ocean signals reinforcing each other at the same time is a genuinely uncommon setup, and it is part of why some forecasters are describing this specific winter as capable of producing impacts beyond what a typical strong El Niño alone would create. The Indian Ocean dipole works through a broadly similar mechanism to El Niño, just centered on a different ocean basin entirely, a temperature contrast between the western and eastern Indian Ocean that shifts regional rainfall and, through broader atmospheric connections, can influence pressure and jet stream patterns well beyond the Indian Ocean itself. When a positive phase Indian Ocean dipole develops at the same time as a strong El Niño, the two tropical forcing patterns can reinforce rather than compete with each other, effectively adding a second source of atmospheric energy, pushing global circulation in a broadly similar direction. Researchers tracking this combination this year have specifically noted that its emergence alongside an already historically strong El Niño gives this particular winter forecast an additional layer of supporting evidence, one more independent signal pointing toward the same general outcome rather than a single ocean basin's influence standing alone. Now, let's walk through what this pattern flip is actually expected to mean, region by region, because the impact of a split flow pattern is never uniform across the entire country. It depends heavily on exactly where you sit relative to that division between the two jet stream branches. The Gulf Coast and Southeast are expected to sit squarely in the path of the amplified southern jet, facing a stormy, active pattern with elevated flood risk as repeated, moisture-rich systems track through the region. The Northeast faces a particularly difficult transition, since the region is already reeling from a summer marked by repeated flash flood emergencies, including a recent storm that killed at least 2 people and shattered Albany's all-time 2-day rainfall record. The Pacific Northwest and Northern Rockies sit on the opposite, considerably drier side of this developing split. The same high-pressure anomaly responsible for pushing warmer air into the northern tier of the country also tends to deflect Pacific moisture northward and away from Washington, Oregon, and the Northern Rockies specifically, meaning below normal rainfall is currently projected for the region heading into fall. For a region that has already spent this entire summer fighting some of its most severe wildfires in decades under persistent drought conditions, a forecast trending toward continued dryness, rather than meaningful relief, is a genuinely difficult signal since snowpack deficits building in the Cascades this winter would carry direct consequences for the region's water supply heading into 2027, extending exactly the kind of drought stress that fueled this year's fire season into another year entirely. This is precisely the kind of outcome that separates a genuinely useful seasonal forecast from a simple assumption that any big weather pattern automatically means relief is on the way for everyone equally. Communities across Washington and Oregon that spent this August watching fires like the Sinlahekin and Kaiser Canyon blazes burn through drought-primed landscape, or fighting to contain the grasshopper fire's push into Mount Hood National Forest, might reasonably hope that a major incoming weather pattern shift means an end to those conditions. Current guidance suggests the opposite for this specific region, that the same split-flow configuration bringing relief and heavy precipitation to California and the Southwest is simultaneously working to keep the Pacific Northwest on the dry side of that divide, meaning the drought conditions responsible for this year's fire season could persist into a fourth consecutive year without the kind of wet winter reset the region genuinely needs. The Southwest and the higher elevations of the Southern Sierra, along with the mountains of southern Colorado, sit on the classic winning side of a strong El Niño pattern, positioned to benefit from that amplified southern jet stream delivering frequent, moisture-rich storm systems throughout the winter season. California, more broadly, is expected to trend wetter across the board this winter as well, continuing a pattern that, according to recent research on how El Niño interacts with atmospheric river activity, could bring an elevated risk of the kind of clustered back-to-back storm sequences capable of producing the state's most severe flooding winters. Further north and east, the Great Lakes region and interior New England face a somewhat counterintuitive outcome for anyone assuming a big El Niño automatically means a snowy winter everywhere. Historical NOAA analysis shows that moderate to strong El Niño events have consistently reduced seasonal snowfall totals across much of the Great Lakes and interior New England, since warmer stretches tend to interrupt otherwise productive storm patterns and increase the odds of mixed precipitation and rain rather than accumulating. Snow, even though a well-positioned coastal storm, could still occasionally produce a significant, memorable nor'easter along the way. That counterintuitive outcome trips up a lot of people who assume a historically strong El Niño automatically translates into a historically snowy winter across the board. The amplified southern jet stream responsible for California and the Southwest's wet, active pattern draws much of its energy and moisture away from the interior, Northeast, and Great Lakes specifically. And the milder air pushing into the northern tier of the country as the polar jet retreats further north tends to work directly against the kind of sustained cold needed to turn precipitation into accumulating snow rather than rain or a messy mix. Ski resorts and winter recreation businesses across interior New England and the Great Lakes region have specifically flagged this pattern in their own planning, treating this winter as one where individual memorable storms remain possible even as the overall seasonal snowfall total trends below what residents in these traditionally snowy regions might otherwise expect. The timeline for how this pattern actually unfolds matters as much as the regional breakdown itself. The World Meteorological Organization's window for this El Niño's most rapid intensification runs through September, meaning the pattern is still actively strengthening as this video is being made. The event's peak is currently expected sometime between November of 2026 and January of 2027, before gradually fading through the remainder of the winter and into spring. The regional heat and drought pattern already gripping much of the central United States this August, alongside the notably stormier conditions already developing across parts of the Northeast, are being described by forecasters as the opening signals of this larger shift, the pattern beginning to establish itself well before its full winter intensity actually arrives. It is worth hearing directly from officials about how much confidence to actually place in this outlook, because even meteorologists who are genuinely excited about the strength of this signal remain careful about overpromising specific outcomes. NOAA's Ken Graham offered a necessary note of caution alongside all of this analysis, stating plainly that every El Niño is not the same. Each one carries its own unique imprint on the country's weather. Stronger events make certain impacts more likely, he explained, but they do not guarantee them. That distinction matters enormously heading into a winter this many forecasters are already treating as historically significant, the broad pattern, a split-flow jet stream driven by an exceptionally strong El Niño is about as well supported a seasonal forecast as meteorology currently produces, but the precise details, exactly how much snow falls in a specific city or exactly how severe a specific storm turns out to be, remain considerably less certain this far in advance. Given everything currently known about this developing pattern, here is what is actually worth doing depending on where you live. If you live anywhere across the Gulf Coast, Southeast, or Northeast, this is the time to review your flood insurance coverage and confirm it is actually current, since standard homeowners insurance typically does not cover flood damage, and enrollment often involves a waiting period before new coverage actually takes effect. If you live in the Pacific Northwest or Northern Rockies, do not assume this coming winter automatically solves the drought and wildfire risk built up over this past summer, since current guidance points toward continued dryness rather than meaningful relief in your specific region. If you live in California or the Southwest, prepare for an active, potentially flood-prone winter by clearing gutters and drainage systems well before the first major storm arrives. And if you live near a recent wildfire burn scar, understand that your mudslide risk is elevated specifically because of this pattern. And regardless of where you live, keep a basic emergency kit updated and ready, since a pattern flip of this scale tends to produce more frequent, more disruptive weather events across a wider stretch of the calendar than a typical season would. That preparation is worth starting now, specifically, because the window for taking meaningful action tends to close faster than people expect once a pattern like this fully locks in. Flood insurance policies typically carry a waiting period of 30 days or more before new coverage actually takes effect, meaning purchasing a policy after the first major storm has already been forecast is often too late to matter for that specific event. Clearing storm drains, gutters, and drainage channels is dramatically easier and more effective when done during a calm stretch of weather than in the frantic hours before an incoming system arrives. And any household emergency plan is only as useful as everyone's familiarity with it, meaning a conversation now, while the pattern is still developing rather than already delivering its first major storm, gives your entire household genuine time to actually absorb and practice the plan, rather than trying to improvise it under pressure. The pattern currently taking shape across North America is not a routine seasonal shift. It is a genuinely rare, historically significant reorganization of the jet stream, driven by an El Niño event forecasters are increasingly comfortable describing as one of the strongest ever recorded, developing with a level of model agreement rarely seen this many months in advance. Some regions are heading toward their wettest, stormiest stretch in years. Others, including a Pacific Northwest still recovering from one of its worst fire seasons in decades, are heading toward more of the same dry conditions that made this summer so dangerous in the first place. That contrast, one part of the country bracing for too much water while another braces for not nearly enough, is really the defining feature of a split-flow winter. And it is exactly why treating this as a single national forecast misses the point entirely. There is no version of this winter that arrives uniformly good or uniformly bad for the country as a whole. There's only the specific version arriving for your specific region, shaped by exactly which side of that jet stream split you happen to live on, which is precisely why understanding your own region's placement within this pattern matters so much more than any single national headline ever could. We will keep tracking this pattern as it continues to intensify through September and beyond, because very few forecasts this far out arrive with this much genuine scientific weight behind them. If you want those updates the moment they land, subscribing is the way to make sure you do not miss them. And if you live anywhere in the country right now, tell us in the comments what this summer's weather has actually been like where you are, because understanding where each region is starting from is exactly what makes a pattern flip like this one worth watching so closely, and the honest, ground-level comparison between now and whatever arrives this winter will end up telling this story better than any single forecast graphic ever could. Stay prepared, and we will see you in the next one.